Hello, this is day 6 from Unit 4, which is Chapter 3B, and this is basically a review of days 1 through 4, and day 5 was a review of days 3 and 4. So I'm just going to do a couple examples. If we're going to graph each of these functions and its inverse, we kind of need to know a few things. One, we can use Desmos, but we should know just basically what this graph looks like. It's just a translation of the parent function, right 3. So the vertex would be there, and it's just going that away and that away. And if we, one quick way just to check your work would be if you go in Desmos and just swap the x's and y's, and then I will turn the graph on. You see in green, it's now going off in that direction. You can see them superimposing each other like that. We would see that it's just at 3 on y, going those directions. It is important, however, to know how to solve things like that. So, if this were, we would graph y equals x plus 5 to the third minus 2, and this is not difficult, just knowing the general parent function x to the third graph goes to the middle, kind of like a snake thing. But we are shifting it left 5 down 2. Its vertex. And then in order to actually find the equation of the inverse, when we swap our x's and y, x equals y plus 5 to the third minus 2. So I'll solve this really briefly because it's just a review. Add 2 x plus 2 y plus 5 to the third cube root. So we have cube root x plus 2 equals y plus 5. Subtract 5. So cube root x plus 2 equals, x plus 2 minus 5 on the outside equals y. All right, so that's an example of the inverses. We could find the inverse, which is pretty much what it's asking here. Do the same thing. So you would see how we got cube root of x plus 2 with a minus 5 equals y. I solved it up there already. And we could tell if its function, if its inverse is a function by just looking at the original graph, and using the horizontal line test. Horizontal line test, I'll scroll up to this graph. Horizontal line test on this, we see that no matter where I draw a horizontal line, it's only going to cross the graph once. So this is the inverse is a function. Okay. All right. Try to do one of these, maybe two. If we want to see one quick way for a piecewise function to see if it's continuous is to directly plug in the point of discontinuity, if there is a discontinuity. So we would just say, well, let's do -1 for that top function and -1 for the bottom function, and just simplify. -1 plus 2 is 1, -1 squared is 1. What that means, since we plugged in -1 on both sides to the left, so this is all x values that are less than or equal to -1, we get 1, so that would be the point, -1, 1. When we plug in -1 to the right, all x values greater than -1, we get 1 again. That means that it doesn't, our graph doesn't lose its continuity. It picks up right where the -1 left off and at the same point. So this is not, this is going to sound kind of weird, not discontinuous. And there's an easier way to say that. It is continuous. Discontinuous. Okay. It is continuous. You could do the same thing for this guy. One thing I want to touch on, though, in number 15, we right now see this as x can't be 3. X can't be 3. And generally, when we find a number in the denominator that x cannot be, because we would get a divide by 0 error, or it doesn't exist at 3, that's usually an infinite discontinuity. There's an asymptote there, usually. But we should check it out and make sure, because sometimes this could, the function on the bottom, the x minus 3 squared, what it's made up of could cancel out with something on the top, making the x be able to be 3 if I simplify it. So let's see what we get. X plus 3, and then if we factor this, there's nothing really factor, but you could write it out like this. And we see that no, x really can't be 3. So this is going to be an infinite discontinuity. We can check and see what it looks like. X plus 3 divided by x minus 3 squared. So it looks like this. There's nothing below the x-axis, and we have an asymptote right at 3. You can zoom way out and see that it's just going to converge basically from the right and the left to 3. So this would then be an infinite discontinuity at at x equals 3. That's where the infinite discontinuity appears. All right, and then the following problems on this day 6 review are all problems that are identical to what we did in day 5. So I'll leave that for you to do. All right, hope this helps some, and good luck.